Subtracting fractions isn't so easy if the denominators are different. So for example, here we have a pizza and it's cut into eighths. 2, 4, 6, 8, right? And we have 5/8 of the pizza. 1, 2, 3, 4, 5. But then somebody eats 3/16. Well, how can you subtract 3/16 from 5/8? The pieces aren't the same size, so you can't figure out how much you have left. So to subtract fractions when the denominators are different, the first thing you do is find a common denominator and make equivalent fractions with the same denominator. Then you subtract the numerators, keep the denominator the same, and then simplify or reduce. So say for example we have 5/8 of a pizza and we want to subtract 3/16. Well, you know I'm going to rewrite it this way because most books don't show it this way, but this is the way I was taught, so it's the way I do it. Alright, so the first thing we need to do is find a common denominator. And we know that 8 will divide evenly into 16, so we can use 16 for the common denominator. That one's going to stay the same. And 8 times 2 is 16, so 5 times 2 is 10. Now we can subtract. 10 minus 3 is 7/16, and this one isn't going to reduce because 7 is a prime number. Let's try another example. So say we have 7/8 minus 3/6. And we're going to find a common denominator. Okay, now 6 does not divide evenly into 8, so we're going to take that biggest number and try multiplying it by 2 and 3 and so on. So 8 times 2 is 16. Does 6 go into 16? Well, no, it doesn't. 8 times 3 is 24. Does 6 go into 24? Yes, it does. So we'll use 24 as the common denominator. Now 8 times 3 is 24. So 7 times 3 is 21. And 6 times 4 is 24. So 3 times 4 is 12. And now we're going to reduce. So 21 take away 12 is 9, gives us 9/24. And will that reduce? Well, using our divisibility rules or just our knowledge of the timetable, we know that both of these divide by 3. So yes, it will reduce, and it gives us 3/8. So 7/8 minus 3/6 equals 3/8.